Okay, so we are talking about sets. Okay, and we said that, okay, we are still on collection. Okay, so it's a collection. It is linear, okay, unordered, mutable collection. Okay, so dictionaries are also unordered mutable collection, and sets are also unordered mutable collection. If both are unordered, okay, then what is the difference between them? Difference between sets and dictionaries are that dictionary will have your key, but sets does not even have a key. So there is no key, there is no index, there is no order at all. Okay. So there are some situations where we don't need order. Correct. So if I tell you, give me 5 examples of something. Now the 5 examples that you give me need not be in specific order, right? If I ask you, give me the 5 steps. Okay, then you'll say, oh, first step, second step, it has to be in order. That's where you use list. Okay, so list of 5 steps, first step, second step, third step. But if I tell you, give me 5 examples, name 5 birds, fruits, whatever, right? The order in this case is not at all important. What is important is, have you given me 5 things or not? Correct? So this is example of set. Now, how do you declare a set? Sets are declared just like your dictionary. So if I do here type of set 1, okay, you should get dictionary because it is a dictionary. But if I add a value here, set 1 equal to 5. Now you see, I have not added the key here. Okay. So if key is not added, then it knows, okay, its key is not added. So it has to be a set. Okay. So now when I run it, okay, you see, it has converted into set. Now you can add values like 5, 7, 8, 11, whatever. Okay. But one, I said you that there is no need for order. So there's no order and there's no need for order. And second property of set is that it will not accept duplicate values. Right? So if I tell you name 5 animals, you cannot say lion, 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 all 5 lions, right? That's not really 5 animals. 5 animals means it has to be different, right? Lion, elephant, fox, whatever, right? So those are your 5 different elements. So you have to name them separately. So if I say here 11, 11, 8, 7, okay? And now if I try to print length equal to length of set 1, okay, and you go through it, it still says 4, okay, because there are 4 unique values. Duplicate values are ignored, removed from the set. Duplicate values are removed from the set. You don't keep duplicate values. Okay. Okay. Now okay, so now let's say, okay, the properties. Okay, what are different properties? Now you must have done sets in your mathematics class, right? Discrete mathematics class. We have set operations like union, intersection, right? Difference. What is union? When you
Like combining.
Yes. Okay. So you can combine 2 sets together, but again, remember the 2 properties. Okay. Order not important, and okay, and duplicate not allowed. So if I say here set 1, for example, you see, and when you print it, okay, see 8 is coming first, even though 8 is, okay, second last, right? Okay. So that's why I'm saying you cannot depend upon the order in which values are displayed. Okay, it's a set. So the order is not important. So you cannot Can you hear me now? Sorry, the mic got disconnected. Now you should be
No.
able to hear me, right?
Yeah.
Yeah, okay, great. So let's the properties here. So I'm going to create set one. Equal to, let's say I'll use same stuff here. Okay, and in set two, I will use 3, 4, and 11, 7. Okay. Now, so I told you union, right? So union, if I try to add set one, okay. So two ways to perform union. One, you say set one, this pipe sign, which is just above your enter key, pipe. You call it as pipe sign. So you say set one, union set two, or you say print set one dot union set two. Okay. Now, when you run it here, you see 3, 4. All the values together. Can you hear me, guys?
I think your voice was cut for
Yeah, but now it is
almost
better,
one.
correct?
Yeah, now I can.
Yeah, sorry. The mic, I don't know why probably it was loose connection. Let's see, it should work now.
Okay.
Okay, so set one and set two combined and the duplicates are removed. So your 8, 11, 7 are duplicates. So 8, 11, 7 are appearing only once. 3, 4, 5 is appearing once, right? So you can perform using pipe sign or using union method. Okay, then you have intersection. Intersection is common, right? It will filter the common part. So if I say print and I say set one dot intersection set two, or I can use set one at the rate, sorry, not at the rate, ampersand. Okay, so it will give you the common part. Instead, why not I do print here? Okay, so your intersection is this function, and then I'll do print here as well, so that you know what I'm trying to do. Oops, wrong copy. Control C, Control V, right? Okay, so intersection, that's the common part. Now I will do difference. Okay, what is difference? Okay, so I'll just show you how we perform different operations here. Okay, so I'm on paint now. You should be able to see paint screen. So let's say this is your set one. Okay, and this is your set two. So when I say union, that means I'm saying this one. Okay, let me use different color. Okay, so I'm saying this one, and this one. And common part will appear only once. Okay, this is your union. A union B, correct? Okay. Now let's say you have another set here. and then we have one more set here. And when you talk about A intersection B, A intersection B, okay, you're only talking about the common part, right? So this is what you get, just the common part, the overlapping part. Now the third one that we are going to do is called, let me use black color again, is called difference or minus, okay, difference, A minus B, okay. So I'm saying from A, you take out B, okay. From A, take out B. So this is, left side is your A, right? And how can I take out from B from here? So if this is entire thing is A, if you take out B, okay, then what is left with you is this, right? So if you have, this is the part of A, right? And this is the common part. So only common part will go, right? Rest of the things you cannot take from. What A doesn't have, you can't take it. What A has, only you can take it. So A has, okay, only this thing which is common between A and B. So common part is gone. This is your A minus B. Similarly, if I have to do B minus A, let's say. So let's say this is your A, and let's say this is your B. So now if I say here B minus A, okay, so this is still A, okay, so maybe what I'll do is I will write what is A and B here, makes sense. So this is your A, this is your B. This is your A, this is your B. This is your A, this is your B. Okay, this is your A, this is B. See, A union B is same as B union A. A intersection B is same as B intersection A. So there, even if you don't mention, okay, what is A and B, it is fine, it is accepted. But here A minus B is not same as B minus A. So you will have to, okay, say which is A and which is B. So from B, I'm taking A. So this is your B. From this, I'm taking A. So I can take only common part. So what is left is this. Correct? So this is your B minus A. These are the three operations. Okay. Then there's one more operation called as symmetric difference. So these are just difference. Okay. Now we are talking about symmetric difference. Symmetric difference means, okay, A symmetric difference B. A symmetric difference B. A symmetric difference B means, okay, there is no difference. Both are same. Okay, what A minus B and B minus A union you take. That is your symmetric difference. A minus B and B minus A, you add them together. So what do you get? So this is your A minus B and this is your B minus A. This is your A symmetric difference B. Then you have join and disjoint. Okay. Joint. So now if you see, all these sets are joined because there is an overlap between two sets. A is a set, B is a set, and there is an overlap between them. So they are, we call them as joint sets. Okay, there is a joint between them. There is a joint. But if I take A and B, something like this. Okay, so let's say this is your A and this is your B, right? Now A and B, they don't overlap. So you call them disjoint. Okay, you call them as disjoint sets. Sets which there is no, so intersection, if you do, you get null set. Okay, so if the intersection is a null set, then we say they are disjoint sets. There's no common between them. Okay. Now, yes, there is one more thing I want to talk about. So let's say you have a set A here, and then you have another set B. Okay, so your B is inside A. So this is B, this is A. Okay, this is B and this is A. So now when B is inside this, okay, we call this as, okay, A as superset and B as subset. Superset means the values of all values in B is already there in A. So A is superset. Okay. And the set which is inside A is called subset. Okay. Now let's see with all these with an example now. So we'll continue to build our program. So we have built union and intersection. Now I'm going to say A minus B. So we will have set 1 difference set B, set 1 minus set 2. Similarly, you can create set 2 difference set 1. So this will be your set 2 minus set 1 and set 1. Now when you run it, so see, you get 3 minus 4. From A, you remove B. So this is your A. From this, you remove B, right? 3 cannot be removed. 4 cannot be removed. 11, 8, and 7 can be removed. No, sorry, I'm saying correct. A minus B, right? First, we'll do A minus B. So A minus B, right? So this is your A. From this, you remove B. So, okay, 3, 4 cannot be removed. 8 and 11 can be removed and 7 can be removed. So you're left with only 5 here. So that's why A minus B or 1 minus 2 is, okay, 5. Now from 2, remove 1. So from 3, 4, 11, 8, 7, remove 5, 7, 8, 11. 5 can be removed? No. 7 can be removed? Yes. 8 can be removed? Yes. 11 can be removed? Yes. So what is left is 3, 4. Okay, they are saved. Now comes your symmetric difference. Okay, so symmetric difference. Okay, so you will say symmetric difference, right? And you put this upward arrow, okay, which is your shift 6. Okay, the key on the special character on 6, number 6. And this is also used to do the center alignment, right? In F string, you can do center alignment. So see, this is union of first two operations. 3, 4, 5. All right.
Yeah.
Okay. Now these are the major operations. Now you have, each of these four union, intersection, difference, and symmetric difference, they have something called as update. So update, you see, this is union update. Okay, update is same as union update. You have, you have difference update, intersection update, and symmetric difference update. So difference between difference and difference update, intersection and intersection update, symmetric difference and symmetric difference update is that when you are doing operations without update, it is like you are saying A equal to A plus B or A union B or A union intersection C or A difference C. It's going to give you a new set of values. You get a new set of values. Okay, but the original value A and B doesn't change. Correct? That's why we were able to get all this. But if you do update, it's like saying A equal to A union B, A equal to A intersection B. So the output will be saved into first set. So if I say set 2 dot symmetric difference update set 1, set 2 will be replaced with the output of this operation. So set update is like A equal to A plus B. Okay, so that is what update is. So if you do not want your original values to change, you don't do update. But if you are okay to change the original value, okay, then you have to say whatever operations and update. Union doesn't need union update. Update itself is union update. Make sense? And you have operations like set one dot is disjoint. Is disjoint set two. So if they are disjoint, it will tell you true. If they are not, it will tell you false. So in our case, set one disjoint set two, obviously they are not disjoint, right? So when you run it, okay, it will tell you false because they are not joined. There is a common element between them. Okay. So last thing that we have to know is, okay, set also has copy. Set also has copy, and this does exactly same thing. Okay, it will create deep copy. Okay, it performs deep copy. Okay, exactly same way that we have seen in list and dictionary. And of course, you have clear. Set one dot clear will delete all the elements. So if I say print, okay, print set one, okay, okay, blank. Set is there, but values are gone. Okay, okay. Then final thing is sets, lists, and tuples can be converted into each other's form. So you can convert a set to list. You can convert set to tuple. You can convert set to tuple. You can convert tuple to set and to list. Okay, that is what we say. So if I say here set 2, now I will say set 2 equal to list of set 2. Now it becomes a list. So if I say set 2 dot, okay, see, clear, copy, index, count, sort, append, these are all list properties that we have seen. Insert, reverse, right? So you can easily convert a set. So now if I need to know the order, okay, I need to know the order. Okay, you need to know the order. Just convert it into list. And then use your whatever you want to do. Like I want to add, okay. And then I will convert set 2 back to set of set 2. Gone. Okay. Okay. So with that, we complete our discussion on sets. Now we need to move on to new topic, which is functions. Okay. So what are functions? Functions, they are predefined, they have predefined meaning, isn't it? So like if you talk about your inbuilt functions, today we use print, right? We used len, we use set, we use list. Now we used so many so far, right? So these are all your inbuilt functions. That means they have a predefined meaning. Okay, we are just using them. Okay, you can create your own set of functions. You can create your own set of functions. So if I say here, we call them as user defined functions or UDF. Okay, so before we talk about UDF, I just want to mention third type, but we'll do it next week sometime. Okay, so it is called as one line or anonymous function. Okay, so we'll talk about it later. Now coming back to user-defined function. So what is the function I said? I said you have few lines of code. How are you? Where are you? Are you coming? Let's say. Now I created 3 questions. Okay, and I can, okay, I need to use them at multiple places. Now see, if I have to use them at the same time for multiple times, okay, I'll be using your loops, right? Iteration. You can use iteration. But if I have to use it whenever, wherever I want, today, later, right? So I will give a name. So I'll say list of questions. Okay, so I'm defining a name called list of questions. This is just like we've been using so far, creating variables, right? Now we are creating a function, so called list of questions. And I'm saying all these 3 statements are inside this list of questions. All these 3 questions or these 3 questions are inside this list of questions. Okay, so what is the advantage? Now, when I try to run it, this is not going to work. Why? Because you have defined it, you have given a name. Okay, so I always say that, when your name is given to you, when you are born, a name is given to you, right? But giving a name doesn't mean that you have to respond to everyone. But once the name is given, now if I call you by your name, list of questions, so you'll say yes. So yes means whatever is there inside this function will be executed. I can write something else. Printing the list of questions once again. So I'll say, okay, list of questions. So whenever you call this function, all the lines of code that is written there is executed. So similarly, when you say print, it has few lines of code written in print, and those things are executed. When you say len, there is a specific program which is written in len, and that is run and gives you the result. Okay, so this is an example of creating a user-defined function. Okay, so I'm creating a user-defined function. So let me create a function, okay, where I will take 2 numbers and perform addition of 2 numbers. Simple function, okay, where you take 2 numbers and you add them together. Okay, so let's do that. I'm going to define a name, correct? Def sum of some two numbers. Okay, let's say this is the name I'm giving it to the function. Okay, sum two nums. So, okay, I need to create bracket, bracket open and close to indicate it's a function, and you give colon, right? Now, after giving colon, whatever the logic, okay, that has to be within this colon, isn't it? Logic has to be within this colon. So sum two numbers, okay, colon, and you put your stuff here. So here, I'm going to say num1 equal to 45, num2 equal to 38, and I'm going to say add equal to num1 plus num2, and now you say print sum of two numbers is, and you say add. Obviously, now when I run it, this is not executed, right? I have to call it. So this is called function definition, okay? Definition. You're defining the content of the function. Okay, you're defining the content of the function. This is your function definition. And now we are going to do calling the function. You call. See, definition, calling. So definition will be done only once. Your naming will be done only once, right? But you can be called 100 times in a day, right? So you define a function only once. Okay, but you call, so this is why we say that there is a code reusability. You are reusing the code. You define it once and call it again and again and again multiple times. Okay, so here I will go and say sum two numbers. And see, calling has to be done after you define. So if I try to call before defining, already PyCharm is giving us error. Okay, it's not defined. Okay, you have to define it and then use it. Sum of two numbers is 83, 45 plus 38. Okay. Now you see, this function is not very useful. Why this function is not very useful? It is a function, good, but it is adding always 45 and 38. Right? So, okay, so if you want to make it something dynamic, you will put input, int of input, right? Then it will ask. But let's say you already got some two values from some other source. Okay, you're not asking the user. You got, you got two values from some other source. Okay, let's say in your main program you have already got the data. Okay, from somewhere. Now you want to add two numbers. This is not useful, isn't it? Why is this not useful? Because it is asking for the value, right? Now, if it is asked or it updates the value, okay, then if you already know the value and you don't want to take user, you already have some value, you want to use that value for addition, then you'll have to write different function. Isn't this function is not useful? So our objective is to write a function which can be used in multiple places, multiple times. Your function has to be very generic, okay? So that, see, if it is not very generic, very specific, it will have very less usage, right? You'll have to end up creating multiple functions for each of the type. Hard work, okay? But if you create a function only once and make it more generic, it's smart work, right? Because you can call it multiple times based on your requirement. So in this case, what I'll do, okay, let's say, I got some value x equal to 38, y equal to 67. Okay, now I want to add these two numbers. I got this value from somewhere. I cannot use this function because these two functions takes n1 n2. Even if replace with input, it is going to ask the user new set of values. It will not have access to the existing value. So then what we do is the function definition of no input argument. Okay, now we will define, okay, second function which says function definition of taking input argument. Okay, now we want it to take input argument. Okay, so I can't have two people with same name, right? I have to change it something else. I'll say sum of two nums 1. Okay, so that way this function is different. Okay, so if I want it to be very strict, I can call this function. If I want to be very generic, I can call this one, right? So, okay. So now see this, okay, this function, I need to pass two arguments. I've already got the values. So I don't want the function to come up with its own set of values. So I'll be passing the two values. So you will say here num1 comma num2. Now when you say num1 comma num2, okay, and now when I call this function, here I will say x and y, right? So we are okay. So we're calling the function here by passing two values. We are calling the function by passing two values. Which are those two values? X and y, isn't it? So x will go to, okay, I can print it here, okay? Print num1 equal to num1 and num2 equal to num2, right? So see, x goes to, x is 38, right? So x went to the first value, which is num1, and y went to second value because we mentioned x here. Now this program is more generic than the previous one, right? If you're getting value from some other function, some other application, you can take those two values and you can pass it to this function without making function ask the user to input the values. Okay, you want this existing value to be used for addition, not the new values, isn't it? So this is called calling function by passing values. And this is defining function of which will take the arguments. Okay, so this is function type 2 that we are talking about today. So if we talk about print takes argument, right? Print can take any number of arguments, okay? So, but this one takes only two arguments. All good so far?
Yeah.
Okay. Now, there is one more function definition. Now, let's say, see, it is printing the output. I don't want to print the output. Instead, I want to use this to pass it to some other function or use it for some other purpose. Okay, instead of displaying. So if you want to display to the user, then this is great, right? This is good because you are displaying. But I don't want to display. Instead, I want to use it for some other purpose. I want to use it to pass to different variable or use it as input something else. Then there you don't want to print it, right? You don't want to print it. So we will return the value, not print it. So this is function definition of taking input argument and returning values. Okay. So now it will not print, but instead return it. So I go here. Okay, so this is the same thing, right? Yeah, this is your num1. I'll make this num2. And it will take the value, not compulsory, but you can have the value. But here instead of printing, okay, you want to print in different format, let's say. Okay, you want to print in different format, or you want to do something else with it, not just print it. Okay, then printing is not what you want, then you will make it your function even more generic. Say, okay, take the values Just add and return. Don't do anything much, anything more than that. All right. So how does it work? So when your function is passing any value, you need to catch it. So here, calling function by passing two values and catching the return value. Value is getting returned, right? So I will say here, okay. So you have to catch it, right? So I'm going to say result here. Okay, now when you say result, that means you're saying, okay, add two numbers and whatever is the output, you please put it in the result. Okay, so here we will pass X, like let's say 27 and 37, let's say. If I say X and Y, the same values will be passed, but I'm changing the value now. And now we'll say function has returned result. Okay, so function has returned 64, 27 plus 34. So if you want to display as per your wish, as per your plan, then you want to make your function even more generic, right? So you added two values, accept two values, great, but return also, don't let it decide what it should do with the output. Let it pass and let you decide for every program what you want to do, isn't it? So this is called as return type. So we have seen function without input values or without function return value. We have seen a function with input value. We have seen a function with return value. All right. Next, okay, function is not enough. We have a lot of things to do. We'll do one more small part and then we will end it here for today. Okay, you have a lot of things to practice over the weekend. Please follow the blog. Okay, all the informations are there. Okay, every code that we did in the class is there. Video links are there. Please use next 3 days. Monday we are not meeting, right? Please use next 3 days to practice, please. Promise?
Yes.
Yes, perfect. Okay, so now you see here what I'll do. I'm going to take the same program and let's say I pass only one value. Then what happens? Exit code 1, error. And what's the error? Sum to nums2, okay, missing one required positional argument num2. Okay, so see here. Keywords, positional argument. That positional means when you, okay, so actually it should be here. Okay, first one or second one, both you can use, same logic, right? Positional arguments. So these are arguments and, okay, so let's take required also. So the arguments that you're passing are both required and positional. Both required and positional. That means num1 and num2 have to be given. Num1 and num2 have to be given and given in the same order. So that's why when I gave only one value here, okay, it says num1 got the value. It says num2 is missing. One value is missing and that too num2 is missing. Okay, because num1 took the first value in order. So this is called as required positional arguments. Okay, so these are your required positional argument. This is your required positional argument. Required means you have to give and in the same order. So what we just did, these two examples are your required positional. Of course, when you say required and positional, there could be opposite of non-required or positional, non-positional, right? So the opposite of non-required is called default. So I'm going to create another function here called def sum2 function. Okay, and I'll say it 3. So if I say 3, this is also required and positional. Now I will say default positional. Default means take a default value to whom I'll say num2 equal to 9. Now, when you say num2 equal to 9 here in the arguments list, okay, not inside here, that means I'm saying if num2 value is not given, read it like 9, read it as 9 or whatever you mentioned, 0, -1, whatever you give, that will be taken as default value. So now it is not dependent on the user to give it the value. Isn't it? It's not dependent on N2 to take the value. So here, okay, I will say 3. Why 3? Because I want to call this default argument. Now, default argument, okay, now if I call, let's say, let me call it 2 times, okay? One is 27 and 37, and second, or maybe say 39, so that they are different, it look different. And this we're passing only one value. So now if you see here, num1 is 27 and num2 is 9. From where did 9 come? 9 came because we gave default value as 9 and we are not passing any value here. But default value is 9 here also, but we are passing the value 39. So when you pass the value, it will take the value that you pass. Okay, only when you don't pass, it will look for the default values. If you don't pass, it will look for default values. Okay, so this is an example of positional, because again, N2 is second, so N2 will be taken, but default, not required, default value. With me? Okay, we'll do one more and we'll end the day here, and tomorrow we'll take exam, not tomorrow, Tuesday when we meet, we'll take examples and discuss. But please do practice, guys. Okay, we are now into level 2. Okay, we have done level 3. In fact, level 1 was up to loops, level 2 was collections, level 3 is functions. Okay, then next level is class and objects. Class and objects, when we complete, that is like minimum Python. So when you say you know Python, you should know up to class and objects. You should know whatever we have done so far, including functions and classes is the last topic. So, okay, this is what they expect you to do minimum. We're going to do few more stuff, okay? But when you say that, okay, I know Python, this is what they expect you to know. Make sense, everyone? Okay, so when you say that I know Python, they expect you to know up to class and objects minimum. Okay, okay. So this is your default. Okay, I have not given value for 27, so it has taken default value 9. But when you give it, it will take the one that you give it. Now, how do you make values non-positional? How to make arguments non-positional? Okay, now for position, sorry, for default and required, we had to change the function definition. But for non-positional, you have to change the way you call your value. So if I take the same one, okay, same, num2, here I will say num2 equal to, and here I will say num1 equal to. See, in function definition, num1 is first and num2 is second. Okay, if num1, okay, let me show you. Sorry, num3, right? Num3 are dealing with. Okay, so in num3, okay, num3, you have num1 and num2. Okay, but I'm saying num2 equal to 27 and num1. So now when you run it, the last one, you'll see, okay, num1 is 39. So it should have gone to this 27 should have gone to num1 there. But when you use keyword, okay, so you're saying how to make arguments non-positional by using, we call it as keywords while passing the value. Okay, so now you say num2 equal to num1 equal to, now when you say num2 and num1 equal to, whatever value you assign here, that will be assigned to the variables up. Okay, it need not be in the same order. Yes, with me? So with
Yeah.
that, we will end our discussion today. Okay, I want you to practice. There's one more concept left here in types of functions here, which is called as, okay, using UDF. Okay, we're still talking about UDF. How to get multiple level or multiple types or variables. Now here you see, in all the three examples that we did, okay, whether it's required positional or default or keyword arguments, we are giving num1, num2, right? When you give num1 and num2, that means only two values can be passed, or less than two in case of default. But you cannot pass more than two. So tomorrow we'll see how to write a function. Okay, not tomorrow, Tuesday. We'll see how to write a function, okay, where with one variable you can give multiple values. So it can take input as multiple values. Okay, one variable which will store multiple values. We'll see it tomorrow. Any question before we wrap up? Okay, any questions before we wrap up?